Okay, welcome to U1A1. This is the first video I made on this YouTube channel. My name is Mr. Lupos, and I'm teaching grade 12, sorry, grade 12 advanced functions. So the 4U course online for you. And let me just minimize this here. I had a bunch of videos, but they're all gone. So a whole new set of videos here. This is U1A1, so Unit 1, Activity 1. And we're going to look at a couple things here. We're going to look about just a quick review about sketching. And I have Desmos open. If you haven't tried Desmos, go to desmos.com. And it's a free graphing software, and it's great. And it works on your cell phone. It works everywhere. So just some general stuff here. I think when we sketch, what I'd like to think about is the basic sketches that we know of functions. So some of you, I teach the grade 11 course, university course during my day job over at Beale. And sometimes we don't spend as much time as we should on graphing. So I know some of you have sketched a lot, some of you haven't. So just really quickly, just to go over a couple things. First of all, let's talk about the quadrants. We call this quadrant 1, quadrant 2. Sometimes we do it like that. Sometimes we use Roman numerals. Sometimes we use regular old numerals, but quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So when we talk about the different quadrants, we know what we're talking about here. And then we have y equals x and y equals x squared. So the degree, I don't know if you remember this or not, but you should hopefully do. If you look at the degree of a function, so if you have that, the degree of the function is going to be 7 here, okay? And if you have something like this, the degree of the function here, so if I have y equals x to the 4, x times x plus 3 cubed, you're going to add these up together and it'll be 7 also. So anything that has the same degree has kind of the same general characteristics. So if I have a line, for example, y equals x goes like this. Okay, maybe I'll switch my colors up. Let me get rid of this. And so if I go to sketch y equals x, get rid of that guy, and come back here and draw it in red. If I sketch him, I know that he starts in quadrant 3 and ends up in quadrant 1. So I go from quadrant 3 to quadrant 1. And if I look at y equals x squared, he goes like this. I'll do my best here. And come back up, and he starts in quadrant 2 and ends up in quadrant 1. Now, anything that looks like y equals x, so even though I have y equals x plus 3, and even I have it in factor form like this, okay, x plus 3, x plus 2. I know that my zeros are -3. Remember when you're going to talk about zeros or x-intercepts, sorry, what you'll do is you just change the sign of the number in here. So x plus 3, the root here will be at -3, so here's -3. And the other root here will be at -2. So you change the sign here because what you're saying is when does y equals 0, right? So if here's my graph here. Y equals 0 will cross my x-axis. So I want to know when is this 0? Well, that's when this is 0 or this factor is 0. So when does that happen? Well, that's when x plus 3 is equal to 0. So x is equal to -3. And then you do the same thing here. Okay, if you don't remember that. So my zeros are -3 and -2. Oh, -3 and -2. But I open the same way. I know I have the same general shape, right? Because I have no negative in front here, and I have a degree of 2. So that means that what's going to happen is I'm going to have zeros here and here, and I'm going to go down and back up like this. I don't know what the vertex is just from what I have, but I know that it's going to look like this this parabola here, and it'll start here and go down and come back up, and then it'll keep extending, and it'll start in quadrant 2 and then end in quadrant 1. So a lot of times when we talk about that, that's when x approaches. So if we want to read this thing, and you'll see this later, at x approaches -infinity, so that's infinity sign. So as x approaches -infinity, as I move in the negative direction, my y will go up in the positive direction because xy goes up and down, and it'll approach infinity. Okay, so that's in U1A2, but you'll see that in a second. And then in this case, as x gets bigger as it approaches infinity and goes on in the positive direction forever, y will also approach infinity. Okay, and there's some general characteristics you'll notice here, and it has to do with, is this an even degree or is this an odd degree? And that's why I'm showing these to you here, because I want you to go back and think. The most simple odd degree function that you have is the line. The line starts, if there's no negative in front of the x, it starts in quadrant 3 and ends up in quadrant 1. If there's a negative, what's going to happen is it's going to start up in quadrant 2 and end up in quadrant 4. So a negative, so here if I had y equals -x, and if I had y equals -x plus 5 or y equals -x plus 7 or -2 or whatever, all that's going to do is shift it over. So if I move it over here, for example, it's still negative have a negative slope to it. It doesn't matter. I mean, it's a different line, but I'm still starting in quadrant 2 and ending in quadrant 4. So in general, and I'll show you proof in a second. If this is y equals x cubed, this is, sorry, that's the same as y equals x to the 1, and this has a degree of 1. And if you look at any odd degree, so y equals x cubed, for example, if you want to look what that looks like, well, let's go over to Desmos real quick. Let's put in y equals x cubed right here. Y equals x cubed. If you don't remember what this looks like, and you might not, it's no big deal. The key here, it doesn't matter what's happening too much, except that it starts in quadrant 3 and ends up in quadrant 1. And if you go back to your line, so does your line, right? So anything that's odd will start in quadrant 3 and end up in quadrant 1. So let me just prove that to you. If I want to change that to 5, okay, there's an, oops, I don't want to do that. Let's change that to the power of 5, okay, and then hit enter. I don't even know what I did there. Let's get rid of all those 5s. Let's get rid of that 5 and that 5. Let's throw that here and go. You notice that it has the same sort of shape. And it doesn't have to be with one root. I could have multiple roots. So if I have something like this, y equals x minus 3 to the power of, let's go to the power of, who knows? I don't know, 4. And then beside that, I have bracket. Oh, what's going on here? And then times, and I want to make this odd, x plus 6 to the power of, I don't know, let's make it odd. Let's make it to the power, we want a total degree of 7, so we'll make that 3. You'll notice, and I'll get out here, and I'll get rid of this guy for a second. I'll just show you the blue. The blue starts here, okay, and ends up here. So if I go out, no, I know it's hard to see, but if you go out, that's probably too much of a, I flew too close to the sun on that example. But if you notice, it starts on the left here, it starts here, crosses here, comes back, bounces off here, and goes back up. Okay, so it'll start in the bottom left corner of the graph, which is quadrant 3, and end up in quadrant 1. As long as it's odd, that happens. And if I throw a negative in front of the whole thing, I don't like let's bring this down a level. Let's go down to this here. And even, you know what, let's just make it, just so we can see it a little better. Let's look at this guy right here. Okay, so this guy right here, a little simpler. Okay, it starts in quadrant 3, ends up in quadrant 1. But if I throw a negative in front, you should know what's going to happen here, or you can predict it. It's going to flip. So it'll start in quadrant 2 and end up in quadrant 4, just like your line. Odd degree functions mimic lines. So if they're positive, 3 to 1. If they're negative, 2 to 4. Let's look at our old friend, the parabola here. X minus 2 all squared has a root of 2. Right? Change that sign. There it is. Starts in quadrant 2, ends up in quadrant 1. Let's deal with the negative first. Let's flip it. Okay, flipped. Okay, anything that if you have an even degree function, it will start in quadrant 3 and end up in quadrant 4. Okay, just like your parabola. Think of your parabolas, your basic parabolas. And if I want to change this and take it up a level, 6. Okay. Oop, sorry. Bam. Not 66. Well, 66 even too. Let's leave it at 66. Okay, I'm starting, if you notice, I'm starting in quadrant 3 and I end up in quadrant 4. And if I flip that thing, okay, I'm now down here. And if I want to add another root, I might be going too far here. But let's say I add another root. Now I have an odd, and the odd starts, it's hard to see, but you can, if you look closely, let's just change this. If I do this, you'll see it starts in quadrant 3 and ends, or quadrant 2 and ends in quadrant 4. Okay, so now this is back to my line. I have 4 and 1. That's a power of degree of 5, sorry. So it's odd, negative, starts in 2, ends in 4. Okay. The only other thing I want to point out is if we have our roots, this is kind of neat too. Let's go back to the blue guy here. Let's get rid of the red one and go to the blue. If I go back to this blue one here, and I have this one here, and you say to yourself, I'm sketching. I don't know how this is going to, like, do I know if it bounces here? And by bounce, I mean, see how this guy comes up here, hits the root, and then stays here, okay? Comes here and stays here. Actually, hold on. One more thing I want to say is this. When we read something and you say, I'm talking about starting in which quadrant, we read graphs like we read English. We read left to right. So when I'm reading this graph, it starts here. It starts on the left, and I follow it to the right. And we read from negative x to positive x. So if you say, no, this doesn't end in this quadrant, it ends in this quadrant, right? I started down here and I drew it this way. Well, maybe that's how you drew it, but that's not how we discuss it, okay? Read left to right like we read English. So the last thing I want to say, and I pointed that out a second ago, is what happens with these roots here? How do I know if this root is crossed and this root is bounced at? And by bounce, think of your parabola, okay? So if I go back to my parabola here in red, what happens in red? Oops. Let me see if I can do this here. Just get rid of that. There we go. And hit enter. And let's go with red. Here, if I go back to my parabola in red, that was negative, but I'll get rid of the negative. You notice, and I'll move it over. I'll change my 0. Let's just bring them over here to 20. So I bring them over here to 20, and you notice it bounces. What happens is it comes to the root, and it doesn't go through the x-axis. It goes back up. So if you want to ask yourself, does it go back up or does it go through? So this guy here goes here, okay? It goes at -6. So if I go back over here, it makes sense that my root's -6. And this one's 3. So how do I know if it bounces like in 3 or if it goes through as a -6? And again, it has to do with odd and even. So if I look here, if it's an even level, if the root itself is to an even power, then what's going to happen is it's going to bounce. And think of your parabolas, right? A parabola over here, x minus 2 in the red, x minus 20, all squared, that has a power of 2 to it. So anything to the power of 2, or let's try 4. Let's go back here and let's try 4. 4 bounces. Let's try 5. 5 goes through. Okay, so even bounces, 5 doesn't. And if you have multiple roots, like in the blue case here, then you're going to have a little more complicated sketch. But if you put together, does it bounce, does it not bounce? I know what quadrant it starts in. I know where it ends in. You can sketch these things. Okay, so we'll spend a little more time with sketching, but let's just do a little practice one last time here. I'm going to go x minus, or let's get rid of all the red. And let's not sketch it yet. And let's see if we can make sense of what it's going to look like before we sketch it. So I'll go X. Okay, and then let me just turn this off so it doesn't sketch. I'll turn the blue off also. And if I go X, and then I'm going to go, X minus 4 to the power of 3 or 4. Let's leave it at that. And then I'm going to add one more here. X plus 1 to the power of 3. So overall, let's look at this. What's the degree of the whole polynomial here, the whole function? Well, I got 1. I don't have a power of 1 in front of that on top of the x, but it's assumed that it's there. Okay, so I have 1 and 4 and 3. That's 8. 8 is even. It's not negative. So when I think of even, I think of my basic parabola. My basic parabola starts in quadrant 1. So if I'm going to sketch real quick, let me just sketch this. If I have a basic parabola, right? My basic parabola goes like this, right? Starts in quadrant 2 and ends up in quadrant 1. Well, this guy here is going to look like that somehow. I don't know what the shape's going to be. I don't know where it's going to bounce or whatever is going to happen here. But it's going to start here, and it's going to go and jump around, and it's going to come back here. Well, where does it jump around? Well, my zeros, if I go back real quick, my roots are going to be at 0, 4, and at -1. So 0, 4. So 1, let me change my color. Let's go with... get out of here. Let's go with green. So I have 1 at 0. I have 1 at, what did I say, 4? Oh, I'm over here, sorry. 1 at 4 plus 4 and 1 at -1. And I know it's this shaped, so I know that I'm going to start up here and I'm going to end up here also. Okay, so just some more sketching stuff. And then I'm going to ask myself, what degree does each root have? So where am I here? Decimals. The x1 is at 1. Okay, so that's odd, which means I can go through. X minus 4 is at 4, which means I'm going to bounce. And x plus 1 is 3. So I'm going to bounce only at the x minus 4, which is the 4. So let me go back here, make sure I get this right. So this is the only bouncer. Okay, so this guy's going to bounce here. And then this one goes through. Oh, and this one goes through like this, and then I'm going to have to come back down like that at some point. So the general shape is going to be something like this, because I have to get to these roots, and I got to figure out how to get there. So let's check it out and see if that's right. I hope it's right. If it's not, I'm going to be honest with you. I'm going to start the video again. So here we go. No, I won't. I wouldn't do that. Where are we? Desmos. Let's sketch this guy. Bam. Oops. Got to zoom in a bit. Okay, my sketch. Let me see if I can do something here for a second. If I can change the scale. Give me 1 second. I'm just going to pause it for the scale. Okay, I think I fixed that scale. So now if you look at it, same thing here in red. I just changed it so we can see it a little better. It does start up here in quadrant 2. It goes down and crosses that negative 1, 0. It then comes back up. We'll figure out where it bounces here, or turns here. I shouldn't say bounce, sorry, it turns here. It crosses at 0, 0. And then again, it's going to cross at 4, 0. And it goes down, through, back to 0, 0, through, comes back down and bounces back up. Okay, so hopefully that makes sense. That's a general graphing way to sketch these things. Practice, and good luck, and have fun on this course. Take care.